Right, we're here at page 2 of section 2.2, and now the book moves you to what is known as two-step equations, putting the addition and multiplication together so you apply both properties. What I've done for you is to create this checklist from the beginning so that nothing is new here in this part of the assignment. It says solve each equation, use the addition and multiplication property of equality. We've already been practicing that using our steps here. So for those of you who've been following along with the videos or in class, the goal and the steps are the same as we've always been doing. In fact, it might be great for you to see if you've got these steps memorized, see if you can fill them in before I get to them here on this page. Start now. For those of you that are kind of jumping around and using the videos just when you need them, these are the same steps that I'm about to fill in that we've done through both sections of 2.1 and 2.2 so far. And now that this checklist that I've been calling it is going to come into play more, especially in these ask and undo steps. So wherever you're at, these steps have been the same now for the last couple of sections. So copy them if you need them for the first time, or see if you can write them out on your own if you've been exposed to them multiple times now. The goal is to isolate x, get x all by itself, or whatever variable it is. Simplify, there's two things you check for simplifying. One is to remove parentheses. We usually do that by distribution, but sometimes all it takes is just plain multiplication or just noticing it's a negative sign. And then you need to combine like terms. Those are two skills that you incorporate when it says to simplify something. You're going to pick a side. You get to decide which side of the equal sign the variable is on, and you're going to use opposite operations to get yourself there. Of the sign that's in front of the x, or the variable, whichever variable it is. Then you're going to ask yourself what's happening to x. I usually note it on the page as a WH, so you can identify what step we're on here. What's happening to the variable? You answer that using order of operations. If you plugged in a number for that variable, what would happen to it? Step by step, as if you had to apply order of operations. Then the solving process here is you undo that by you go in reverse order and using opposite operations. So you reverse the order of the what's happening list or the timeline. We can do it as a list or a visual timeline, and you use opposite operations, and that will undo everything that's happening to x. So if it says add, you subtract. If it says multiply, you divide. And then we're going to check our answer in the original equation. That is going to be critical to make sure we haven't made a solving algebraic error, and to make sure we also haven't made a simplifying or rearranging error in the beginning. So I've mentioned this before, but just so you kind of have a big picture of what's happening here, these first two steps is a way to rearrange the equation back to this likable and familiar ax plus b equals c format. And then the second two steps is the actual solving process, where we're getting x by itself. Keep that straight, keep the goal in mind. You'll be just fine on these, because it's really nothing different than we've been practicing all along. Number 32, 3x minus 2 equals 9. Our goal is to get x by itself. Are there any parentheses involved? Nope, that's been done for us. Do we need to combine any like terms? So on the right side of the equal sign, it's just 9, nothing to combine. On the left side of the equal sign, it's 3x minus 2. These are not like terms. Like terms have to have exactly matching variables with exactly matching exponents on those variables. And then we pick a side here. X is already just on the left side, so again, that's been done for us. We are ready to move on. There's no rearranging we had to do of the equation. We're ready to move right to the solving process. And if you get familiar with this format, ax plus b equals c, if you can recognize it right here, ax plus b equals c, 3 times the x plus a negative 2 is what that's really saying, equals our c value of 9. You know you don't have any simplifying or picking a side to do. It's already in the format where we can practice where we can put into play our solving technique. And so what we do is we ask ourselves, what is happening to that variable? And if you were to, the way you answer that is you imagine plugging a number in for x, and what would you have to do to it? First, by order of operations, it would get multiplied by the 3. Then 2 would be subtracted from it. So the first thing that would happen was it would be multiplied by 3. And then the second thing that would happen is we would subtract 2. And if you were to do that in more of a visual, that's kind of a verbal list, 1 multiplied by 3, 2 subtract 2. Or you could do it as a timeline, put your variable first, x, first thing that would happen is it would be multiplied by 3, then it would subtract 2, and you would read that left to right. Now we get to undo what's happening to x. We do that by going in reverse order. So if you use the verbal list, you would go up the list. Your last step would be your first step and back on up. So you would go up the list, step 1, step 2 to undo it. You would go right to left along the timeline, and you do opposite operations. Instead of subtract, we're going to add. Instead of multiply, we're going to divide. For the timeline, instead of subtract 2, we're going to add 2. Instead of multiplying by 3, we're going to divide by 3. And so let's follow the prescription, the list that we made for cells. Look for that new step 1. You're going in reverse order, remember. So as we go right to left on the timeline, we run into +2. This is what we do first. As we go up the list, we're going to start with step 1, and it also says to add 2. So we're going to start by adding 2 to both sides. And what I get is 9 plus 2 on the right side is 11. The equals comes straight down. The -2 and the +2 cancel each other. That was the whole point. We're undoing what we see happening, and so it goes away. And we're left with the 3x. So we've taken care of the +2. We've taken care of the first step in our undo list. Go to the second step now, and it says to divide by 3. Continue reading across the timeline right to left backwards, because we're reversing it to undo what's happening to x. You're going to divide both sides by 3. And I don't know if this question has creeped up for you before, but the question might be, why do you go in reverse order? And that's a great conversation to have, and it's a great question to ask, because there's an order of operations, and order of operations kind of working from the closest to x out. To undo it, you need to go in reverse. You go from the outside in. Another way to think of it in terms of the analogy in real life is, let's say you, let's see, what would be a great example here? Let's say you packed for a trip, and as you open your suitcase, you decide to put your shoes all along the bottom, then to put your toiletry items in, and then you put your clothing on top, and then you finish with some souvenirs that you're going to take with, or some packages. Let's say you're traveling for Christmas, you're going to take packages with. So you'd have a certain layers of things that are in the suitcase. Well, when you get to your destination and you go to unpack the suitcase, naturally you have to unpack it in reverse order, because what you're faced with first is what you left in there last. So you take the packages away, then the clothing, then the toiletry items, then finally you could get to your shoes. Okay? If you just dig for the bottom, chances are you may not get what you're looking for. So same thing here with solving an equation. So anyway, that was a little detour there. Why do we reverse the order? All right, with the 3's cancel each other here, you're left with x is equal to 11 over 3, or if you want to write that as 3 2/3, I don't mind which one, okay? Neither one is better than the other. Depends on context, what you need in that particular situation. We're just solving right now. There's no particular need for how we're going to apply our answer. But if you look in the back of the book and you stopped at 11/3 and it says 3 2/3, just go, oh, okay, I know those are equivalent to each other. Make sure you know that how to get back and forth from one to the other. And then we would check our answer. And we would put our answer back into the original equation. So we're checking 11/3 in there and see if it works. And in this case, yep, the 3's cancel and I get 11 minus 2. Does that equal 9? Yep, 9 equals 9. This is a true statement. I've checked my answer. I can go ahead and put it in set notation now, 11 over 3. My final answer. Okay, let's do number 40 together. I've got negative x minus 5 equals 5. I check to see, oh, my goal is to get x all by itself, or whatever the variable is. In this case it is x. Are there any parentheses that I need to remove? Nope, done for us. is there any simplifying I need to do in terms of like terms? So on the left side, it's negative x minus 5. These are not like terms, so I can't combine them. 5 is by itself, so we don't need to do that. Next, I make sure that x has picked a side and one side only. It is only on the left side, so we're good to go. Starting with the what's happening to x process. So if we were to plug a number in for x, what it would look like is that negative would get multiplied by the x. And remember how I talked about to convince yourself that negative x is really negative 1 times x? Here's where it comes into play. Here's an example of being able to understand what's happening. It's getting multiplied by negative 1. So the first thing that's happening to x is it's getting multiplied by negative 1. The next thing that would happen is the 5 is being subtracted. So you would subtract a 5. Or you could think of it as adding a negative 5. And when you undo that, you would be subtracting a negative 5, which is the same as adding, which will be what undoing subtracting is here. Okay, and as I talk through anything, if you want to hear that again, or you need to hear it live, make sure you ask. Make a note for yourself and ask, hey, what did you mean by this? That's a great question to bring to class, and especially if it's how I explained it in the notes, make sure you ask me directly when we're going through the try problems up in front. Okay. Now, if you wanted to do this more visually as a timeline, you'd start with x, and then you'd multiply by a negative 1, and then you'd write subtract 5, and we would read that going left to right here. Now it's time to undo this process, so we go in reverse order up our list. So step 1, or step 2 becomes step 1 becomes step 2, we just continue on up. All the operations become opposite, so subtract becomes add, multiply becomes divide. I'm not changing any of the signs, I'm just changing the operation. I go right to left if I'm using the timeline version, and that will tell me to do opposite of subtract, which is add 5, or opposite of multiply, which is divide by negative 1. And again, we're going right to left. And then you take that first step, which is add 5, whichever way you look at it, your first step is to add 5. I'm going to go ahead and rewrite the entire equation here, negative x minus 5 equals 5, so we can start fresh. And I'm going to add 5 to both sides, because what I do to one side of the equal sign I do to the other. That's critical. That's the critical rule for solving. I get negative x equals 10, so I've done my first step here on both of these. Now my second step says to divide by negative 1, or as I continue along reading the timeline right to left, I bump into divide by negative 1. So that's what I'm going to do. I use the fraction symbol to show division and when I divide a negative by a negative, that becomes a positive. Or if you imagine that being a negative 1 divided by negative 1, they cancel each other out. Either way you want to think about it, you're left with x. And then positive 10 divided by negative 1 is going to be a negative 10. And now I get to check it. Back in my original equation, negative x minus 5 equals 5. Here's where my little system comes in handy for me. I first write the equation and leave a space for myself where x is. So I still see the negative out in front. There's my space for x minus 5. Then I take my entire answer of negative 10 and plug it in. So I've got negative 10, or negative 1 times negative 10. That's going to become positive 10 minus 5. Does that equal 5? And yes, 5 equals 5. It's a true statement. So I have checked it, and now I can put my final answer in set notation form of, where was it? Negative 10. Okay. All right, so take a moment to talk this through with somebody, talk it out, especially if you have seen this list of steps several times. It might be time to start putting it into your own words. In fact, if we copy this multiple times again in the next set of notes, go ahead and start putting it in your own words, or see if you can do it from memory before I write them down. The reason I write them down so many times is for those who are kind of video surfing and finding just the video pieces they need. So I recreate the list multiple times. It's time for you maybe to do it from your memory or put it in your own words. That would be great. It's a great learning process. Get you ready for the exam. Okay, let's see. Oh, you know what? I realized I'm off the screen for those last couple of steps. So let me, we'll move on to the next video, and I will talk through those lines that were off screen. Sorry about that. Okay, we'll see you at the bottom of page 2.